Hi, everybody. Thanks for joining us today. We're going to be talking about data representation in the new version 9 of the Australian curriculum, specifically with a focus on year 7 to year 10. This is session 2, specifically with a focus on data representation. If you haven't already watched session 1, which is the more generic introduction to Grok Academy itself and the version 9 of the curriculum, you can go back and do that. But today we're going to be talking. So my name is Drew Eastlake. I'm an educator at Grok Academy. Previously, I've worked in rural and remote public schools up and down in New South Wales. And I'm joined today by Sharon as well.
Hi everyone, I'm a senior educator at Grok Academy. I was a computer science teacher for 22 years, both here in Australia and also in the US in Chicago for about 4 years.
So what we want to do in this session today is we really want to look at the 3 concepts that are related to data. We want to provide you an overview of the key features of data representation, give you some learning experiences that you can do in class, and share assessment examples. We also just wanted to include there a definition from ACARA on data representation about how it's represented and structured for storage and communication. So what's covered in data? Specifically in data, there's 3 sections we need to address. There's data representation, data acquisition, so which is how we're actually going to get that, and data interpretation, which is how we're going to extract meaning from that data and turn it into information. Today, though, we're just going to focus on representation. So if you're planning to teach data representation, you need to be aware of the content descriptions that are provided in the Australian curriculum. They provide explicit statements about what needs to be taught. We're going to look at those in detail today in both what is needed now in version 9, as well as some of the changes from version 8.4. One of the ways that we really do have lucky for us when we're working with data representation is that it's really easy to apply it to some other contexts. And we're going to talk a little bit about that in some of the activities that we're going to be discussing today. So you can always keep those in mind because that provides a more enriching and sort of more real context for students. And then there's also the achievement standard, which says how that is going to be assessed and how you can determine whether a student has achieved in this particular subject. So we'll look at all of that in sort of a little bit more detail, but we just wanted to give you a really quick overview to begin. Data representation here, you can see how it fits in across from foundation to year 10. And specifically, we're going to be addressing year 7 and 8, 9 and 10. But the other thing that I really wanted to draw to your attention here is that now in year 5 and 6, students should be explaining how digital systems represent all data using numbers and how they can represent data by on and off states or zeros and ones. So one of the big changes into version 9 is that that's now been put down into year 5 and year 6. So it would not be unreasonable to expect a student to have hopefully an introductory knowledge. I know that's not always the case, but it is now down there before they come into a year 7 and 8 specifically. So let's start off by looking at year 7 and 8. In version 8.4 of the curriculum, you can see here it says that we used to have to investigate how digital systems represent text, image, and audio data in binary. Now, that's been split up into 2. We've got investigate how digital systems represent text, image, and audio data using integers, and explain how and why digital systems represent integers in binary. And I think these are a really good change. I think they're a lot more explicit in what they require students to do in version 9 now. And by breaking it up into 2, you can really make sure that students are addressing each of those points because although they are very similarly linked, there is clear definitions that they need to know to carry over, particularly as they progress into year 9 and 10. So here's the achievement standard, and I've just highlighted a very brief section there. It says that they're going to represent data with integers and binary. And what you'll see in our presentation today is that's where we're going to place our focus in, is binary and integers in 7 and 8. So we're not going to look at spreadsheets as much. That's in another data section. We're just going to look at how they represent it with integers and binary. The Australian curriculum provides elaborations, and these elaborations are a suggested way that you can address these particular outcomes in your class. They are completely optional. One of the ways that they have greatly improved in version 9 from version 8.4 of the curriculum, is they are a lot clearer in their description, in what they require you to do, or what they suggest that you do. There's more there. By no means do you have to address all of these if you would like to, so long as you are addressing that outcome. The elaborations are purely just more detail. And I know that for myself in my own teaching, I find the slightly more abstract concept of audio to be a little bit harder for students to grasp compared to images and compared to text, where they do have more familiarity. By representing it with whole numbers and amplitude there, you can tick off that box if you need to with these abstract concepts, because it says that we just have to investigate how they represent text. Investigate's the key word there. Right? We're not requiring them to create anything. We're just asking students to investigate how they do this. So you can see here we've got 4 elaborations, explaining how we use the Unicode character set. For example, uppercase and lowercase letters, punctuation and emoji. We're looking at audio and amplitude and sampling rates. We're looking at bitmapped images and how we could represent RGB channels. And then we're looking at how a digital system converts audio data to integer as it stores and records. What we want to do in this particular presentation is we want to give you concrete ways that you can implement some of these in your class. By no means are they all of them, but we would like you to take some really practical things back into your classrooms for you to implement. And then again, for the how and why digital systems represent integers in binary, you can see there that we've got counting in binary from 0 to 31, and talking about bytes into bits from 0 to 255. We're looking at how digital systems represent data in binary, so by converting a character and then converting that again. And we're looking at how circuits can perform binary operations as on-off states, showing how circuits with switches can represent AND or OR gates. So long as students are adequately able to explain how and why digital systems represent integers in binary, that's your choice as a teacher in your classroom. We'd like to show you some activities of how you can implement these particular outcomes in your class. The first one is a Grok course. It's the Data Representation Grok course. We really like this course because, as with a lot of the courses on Grok, teachers are able to do these themselves and learn what it is your students are going to be doing before they do it. You can jump in and do the course first before you assign it to your students. If you're feeling as though you're out of area, or you maybe just need a little bit of a refresher and a brush up yourself, it's a great opportunity for you to do that. It uses simple Python programming to conduct projects. There's learning tasks and accessible problems that require students to apply that knowledge. And we find that the best way for students to learn this is in conjunction with your own teaching. So you would be presenting some of the theory that you would need as part of your regular classes, and using the Grok courses to reinforce that knowledge. It is self-paced, but you as a teacher can monitor the tasks that students are doing, where they're up to, and there are formative accessible tasks built into it. It is just on the Grok website. You can see down the bottom, we get them to look at text and binary and images and audio and emojis as well to represent that Unicode part. One of the things that I do find is that ASCII is a much better place to start students. By limiting the character set that they can do and looking at only 7 or 8-bit binary, you're able to then differentiate and progress harder into Unicode for students who might be more familiar with concepts, while also still addressing the simpler version of ASCII for your students who may only be seeing binary and character representation for the first time. In these Grok courses, if I pick binary as the example, you can see here we've got some videos. We explain what binary is, and then they do a little assessment here of just a multiple choice question of selecting odd binary numbers based on the problem that was here. You, of course, as the teacher, also have access to the solutions and the teacher notes as well. should they be applicable? Should there be more that you as the teacher would need to know in order to have students complete these tasks? And there are a series of tasks here representing all of that for binary, and then going into images and audio and emoji. The binary image creation. So I'm going to throw to Sharon to present this one to you.
Okay, thanks, Drew. So one of the activities I wanted to share with you today is looking at how we can use binary to represent black and white images. Now, I've created an unplugged worksheet that you'll have access to after this presentation. For today's activity, I just wanted to do it electronically to show you how you can do it in a spreadsheet. And this spreadsheet is also available after the presentation. So given a string of binary zeros and ones, we can transcribe them into an image of a predetermined size. So I've set up conditional formatting on this image. It's 13 pixels wide, 8 pixels high. And basically the students go through and they put in their zeros and ones. So I think there's about 13 zeros to start with, having done this a couple of times. And you see that, well, you can't see it actually changes to white, but then if I put in a 1 value, it will change to the black. Okay, so the students go through and they transcribe these down here. If they make a mistake and accidentally flip a bit, so it's a 1 instead of a 0, then the image won't be representative of what it was supposed to be. If we look down the bottom, we've got the activity and the solution, and I've put the solution in here as well, so teachers can actually see what the image looks like. So it's just a Space Invaders image. Like I said, we've got this as an unplugged activity worksheet as well, where they can actually sit and colour in those values. This is a nice activity to get started in how binary is used to represent images, and then you can move on further looking at the Grok course that Drew was showing previously in looking at colour images using RGB values.
The last activity that I wanted to show for Year 7 and 8 is this binary and ASCII treasure hunt. There is a little bit of setup to this, but we will give you all the files for it. And it's a really fun way to reinforce some of the concepts that students will be learning about with binary and data representation. If I bring up the folder here, in this binary folder, what you'll get is a bunch of files. Now, I've got some of the merged ones here in my own copy. Yours will not have the pre-merged ones already. It starts off with this treasure hunt Excel file. And if we open this Excel file up, what you see is this huge spreadsheet. And what the point of the task is to have students go around the school to conduct a treasure hunt. So they would get placed into groups. And you can see here we've got the groups are based off famous contributors to the technology industry, which in itself can lead to a separate activity. You can see there's also a lot of female names in here. So that could be a separate research, separate discussion point, a task for students who finish early to say, hey, who was that person? Do you know what their contribution to the industry was? And a bunch of different stops for them to complete. So you can see here that if I look at team 1, the Bill Gates team has to go to the front office, the gym, G1.5. These are specific to my school, but I'll show you how to change them for your school in a moment. Student services, another room, and they've got to go from one location to the next in order to solve the treasure hunt. But they don't know how to get there. What they get given is a string of zeros and ones. And that string of zeros and ones, they then have to decode. It's just a simple ASCII code, but they have to decode it in order to find out where to go next. And down the bottom here of this sheet, you can see here I've got the location and the binary code associated with it. Now, this is where that little bit of work comes in. You have to set the locations to be locations for your school context and then calculate the binary from that. If your binary skills aren't up to scratch, it's not a worry. You can also just find a converter online that can do it for you. But you're going to put the binary code in here in this same 1 byte 8-bit binary. And then what it will do is it will automatically update these here. Then students have a little conversion chart here, or you have a conversion chart if you'd like to do it as well, where they can begin to sort of take some notes about how they would represent it. So the first thing you'll want to do is you'll want to fill this out, and you want to make sure that this spreadsheet is up to scratch. Because once you've done that, then what we do is we come into this sheets file here, and it'll say it can't find the data source that it needs. So I'll go and find that quickly. That's in here in my spreadsheet. So you'll find wherever you've saved your spreadsheet to, and we'll go open on that, and we'll accept those permissions. Whoop, and it says here, open range. We're just going to leave that as it is there and press OK. And you get a mail merged sheet. Now, none of this particularly will look relevant to you. What we can do is we can come up to mailings in the Word document and just have a look at a preview of the results. And what you see here is students get given the locations, which you can change and you can edit those out, and also the accompanying binary. So they have to decode each binary string in order to find out what it is, where it is they need to go. And the Bill Gates group has a different order to the Charles Babbage group, to the Ada Lovelace group, to the Steve Wozniak group. So students can't just look at what another group's doing and sort of copy their work. So this you can then print out to students and give them the clues. And they also have, also included in here, is just a really simple printable group divider. So you can print these out and divide your students up into groups for however you need them to be. So it's just a really simple consolidation task in order to have students make sure that they can understand what it is that they need to be doing. So that's a really good way for you to have students make sure that they know what it is they've been doing in binary and to reinforce the concepts that you've been doing in your other teaching. Hopefully you now have a couple of different ways that you can take strategies into your class in order to address some of those year 7 and 8 concepts. But we do also have a year 9 and year 10 cohort. And in 9 and 10, version 8.4 said we needed to analyze simple compression of data and how content data are separated from presentation. And you can see here, this has been split up into 2 very distinct categories. And I mentioned in the year 7 and year 8 example that it was a lot clearer. And I think it's even more evident here. These are very different links that are now clearly broken apart. You can see here that we need to represent documents online as text, structure or markup, and presentation styling, and explain why such representations are important. We also need to investigate simple data compression techniques. Here's the achievement standard. Here's what a student should be able to do by the end of year 10. And you can see that it says represent documents as content, structure, and presentation. Now, if you're familiar with it, you'll probably already be going, oh, that's HTML and CSS and JavaScript. And it is. That's the simplest way that we can address these. We can talk about things like how Google scrapes the web in order to determine what every web page has on it. And if we didn't have those clear structures in place, everything would need to be much more defined in order for Google to be as effective as it is, right? That Google doesn't care necessarily about how the web page looks. It cares about how the content of the web page is there. So when we're looking at the structure of pages, you can see here that these elaborations have been provided. And I really like these elaborations that really do make some of these terms that you might be unfamiliar with a little bit clearer. So we need to represent documents by separating content, structure, and presentation. And you can see that there's definitions for what each of those mean. We need to write web pages using HTML and CSS and explain how the tags separate content from structure, and explain how representing content, structure, and presentation separately allows each of them to be manipulated and stored independently, and why this is important. So again, these are optional, but if you've been given this and you're going, I don't know how to meet this outcome, I really do feel as though these are clear ways for you to have some pathway forward into knowing how you need to meet these in your teaching. We need to use algorithms to identify patterns in data. We need to look at lossy and lossless compression, and we need to examine an image and discuss whether it would be compromised if all the blue pixels were to be replaced by one token and the number of pixels it represents. The key word is, with this one, the key word is investigate simple data compression techniques. You do not necessarily require students to be able to do it themselves. I think with examples of text and images, as Sharon's going to talk to you about in a moment, these are really simple to do, and I think it really does help reinforce some of the understanding. When you get into looking at audio and video, it can be harder for students to be able to do that, and it requires a little bit more of a technical skill. While you do need to investigate them, you do not need to have students do every single data compression and be able to compress data in those ways. Like with Year 7 and Year 8, we do have a Grok course that's available for teachers who might need a brush up of HTML, CSS, but also you can deliver this to your students as well. So this teaches you the basics of HTML and CSS. Again, use it in conjunction with your own teaching, but also use it as a chance to upskill yourself. Self-paced, but you can monitor, and there are formative accessible tasks built in. So let's have a look at that one quickly. It is not a long course. There's only 2 modules. Introduction into HTML and then introduction into CSS. And if I go into them, you'll be able to see these green pips. We have interactive steps that students can complete, which we find helps when students go straight to the assessment task, say, and then not have done any of the reading. So this is a way for you to make sure that students are completing it. And they're very simple things. Edit the HTML to add a starting H1 tag before. And we explain what that means. But for a student to do this, we come up here and here's the HTML that we've got to edit. So I'll add in a H1 tag. And you can see here that I get that instant feedback. I get that I have edited that HTML. The course and the code has recognized that it's missing the closing tag, or step 2. So let's go in and do that right now. There we go. A student can show that they can successfully add one specific tag to their website to code in order to start to structure a website. And there's a heap of different activities like with the data representation Python course, but these ones just focus on HTML and CSS. The real benefit from it comes from that with those skills, the way that you can represent data is it really makes it simple to elaborate on some of the other things that you're talking about. And rather than have a student present, say, a Word document to explain how some of these concepts might work, particularly with compression, if they do this course, they can start to use the website structure, HTML and CSS, to present their information, which also gives you a chance to talk about why it's important that they're structuring it in certain ways and representing things in certain ways. So you can really make sure that you meet that KO2. The other activity that we just want to do to finish up is we want to look at text compression. So once again, I'll pass over to Sharon, who's going to run you through this one.
So just quickly before we look at text compression, I just want to go back to the black and white image that we did previously. We can look at how we can compress images such as a black and white image using patterns, and we're going to do this with the text compression as well. So basically over here I've just began to do the compression values of these zeros and ones that represent our Space Invaders image. And all you do, the first number is the number, the quantity. So we've got 16 and then the zero. So we've got 16 zeros to start with. Then we've got 1, 1, so 1, 1. Then we've got 5 zeros, 5 zeros. Then we've got 1, 1. And then we've got 7 zeros. You can see it get a little bit confusing. And then 3 zeros, etc. So I've just done the first line and just wrapped around to here. So this would be a compressed version of the uncompressed data here. So this activity is a little bit longer. I've also put this, I've also made this available for you as well. So we've got the activity on the first sheet, and then I've got a solution on the second sheet. And with this activity, the students can have different solutions. It depends on what patterns that they identify and what patterns they put into their dictionary. So I'll just quickly start with this and how it works. So I've got a poem here. I never saw a purple cow. I never hope to see one, but I can tell you anyhow, I'd rather see than be one. So the way we compress some text is that we go through and we look for patterns, and it doesn't have to be complete words. It can be parts of words, but it needs to occur at least 2 or more times. And depending on the decisions we make on what patterns we identify will influence our compression rate. So we'll just get started, where you can see that we've got a 1 underscore. I've put underscores in here because it's easier to identify that they need to be included rather than spaces. But when we're compressing, we need to include spaces as well, because they take up storage. So if I click on the first one, I never saw a purple cow. We can see that we've got I underscore. We've also got I underscore on the second line and I underscore on the third line. So what I can do is I'm just going to highlight that I underscore so I don't use it again. And this one here. And this one here, because once we've identified a pattern and we've put it in our dictionary, we can't use it again in another pattern. So now I'll put that I underscore in my first position in my dictionary. Now, the way the dictionary works is that I have a symbol. In this case, I start with numbers up to 9, and then it can be any symbols after, but it can be any symbols that you decide to use. It could even be letters of the alphabet, and that represents the pattern. So when I build my compressed text, I will replace the I underscore with the number 1. Okay, so let's have a look at another pattern. So we can go to our next word, never underscore, and we've got never underscore on the next line. So let's put that in our second position, never underscore. And again, I'm going to highlight that so I make sure that I don't use it again later. And it also helps me rebuild or to build my compressed version. Okay, so let's have a look and see if there's any others. Well, we've got OW, owl, and we've got owl here for anyhow, so let's do that as well. And I'll highlight that. So as I mentioned earlier, it doesn't have to be the complete word. And I'll put that in my dictionary. We've got underscore 1 here and underscore 1 here, so we'll grab that and put that in our dictionary as well. And you'll see that I'll leave off the exclamation mark. That's not part of the pattern. And underscore 1 is our 4th position in our dictionary. Underscore C, so we'll get that one as well. And I'm sure you're thinking, oh, there's another one. She's going to miss that, and I probably will. But that's okay. And I'll highlight this. Okay, so let's say this is our completed dictionary. This is our original text. Now, let's work out what the size is of our original text. And I've already done this previously. I've counted up every single character. So each character, including the underscore, or if it was a space, includes a space, they take up 1 byte. And we'll see on the last line we've got I and we've got an apostrophe. That takes up a byte as well. Likewise to the exclamation mark, that takes up a byte. So adding all of these symbols and characters up together, we get 99 bytes. Okay, so that's the uncompressed file size of our text. So now to do our compressed version, and I'll just start off, I won't complete it, will take up too much time, but I'll show you the solution. The way I can put together my compressed text, wherever I see, and this is a good idea, this is why highlighting works, or putting a line through it if it's the paper version. Wherever I see the pattern in my dictionary, I replace the original text with that, with the symbol in my dictionary. So the I underscore is now going to be 1. And then I've got never underscore, which is 2. So type in 2. And then saw underscore A underscore purple underscore and then C, that's not in our dictionary at all. So that goes into our saw underscore A underscore purple underscore C. And then owl at the end of cow is position 3 in our dictionary. So the first line, our compressed version of our original text, is now 1 2 saw underscore A underscore purple underscore C3. Okay, and we continue doing that for the remainder of the lines. So once we've finished that, then we add up how many bytes we've got in our compressed version, but we also have to add up the number of bytes in our dictionary. So we can see that we only use this part of the dictionary. So this is the only bit that's going to be added to our compressed file. The symbols take up 1 byte, and also the characters in our dictionary. So if we just add these together quickly, it'd be 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23, if I've added that up correctly. So I'm using 23 bytes to create my dictionary, and then I'd add up the compressed values. I'll just flip over to the solution now. Okay, I think no, that's a little bit different. Oh, yep, I've used the underscore there. Okay, so again, there's multiple correct answers. You'll get a different compression rate on which ones you choose. So in our solution here, I've finished those last 3 lines. We add all those bytes up. Our compressed size is 70. With this spreadsheet, I've already put in the formula to do the calculations for you and the students. So we add up our dictionary size, which is 23, to our compressed text, which is 70. So our total compressed file size is now 93. Our original was 99. We got a little bit of compression, not that much. The more patterns we recognize, the more compression that we can get on that text. And we can see that our compression percentage of the original size is 93.9%, about 6% compression. Okay, so that's a nice, quick and easy text compression activity to do with the students. Thanks, Drew. Back to you.
What we have also provided are a ton of different resources that we ourselves have used or are familiar with, as well as everything that we've presented here today. Next up, we have algorithms, part 1. Just also as a reminder, Grok Academy is now completely free for every Australian school, student, teacher, parent, adult learner. So this is thanks to a partnership that we entered into with WiseTech Global. And we just really do want to show you that you can have your students join up and do those Grok courses specifically that we had spoken about. You can get in contact with us. There's a QR code on the screen that will take you straight to our website. And we've got our email address if you need to contact us here. Thanks for joining us, everyone.
Thanks, everyone.